Okay, have you noticed how it seems like everyone is wearing glasses these days? Well, you're not imagining it. There's this huge global mystery playing out literally right in front of our faces. The number of people who are nearsighted is just exploding. And the culprit? It's been hiding in a place no one ever thought to look, inside the eye itself. And when you see the data, you'll see what I mean.
Just look at this chart. That is not a gentle curve. That is a straight up cliff. We're talking about some parts of East Asia where the number of nearsighted 20-year-olds went from 20% to over 80% in just a couple of decades. This isn't just a trend. It's a full-blown modern epidemic, and scientists have been scrambling to figure out why.
So that brings us to the big question, right? What is going on with our eyes? Is it our genes? Is it all the screens we're staring at? Or is it something totally different?
Okay, so before we get to the why, we really need to understand the scale of this thing. And, what's actually physically happening inside an eye that's nearsighting. And this is not some far-off problem. Nope. Right here in the US, about 40% of all adults are myopic now. Think about that. That's almost half of us needing glasses just to see things clearly far away.
So here's the science bit. In a nutshell, with perfect vision, light hits the sweet spot right on your retina. But as you can see here, in a myopic eye, the eyeball itself is actually too long. So the light focuses in front of the retina, which makes everything in the distance blurry. Now, we've known this part for ages. The real mystery, the one that stumped everyone, was why on earth are our eyeballs getting longer? Well, the answer starts in a part of the eye that most of us just completely ignore. It's time to meet the real star of this show, the sclera.
So the sclera, that's the tough, white part of your eye. You can think of it like the eye's protective armor. Its main job is to hold that perfect shape, right? So light can focus properly. And for the longest time, we just assumed it was this simple, static shell. Turns out, we were totally wrong.
And this is the big twist in the story. That wall isn't static at all. It's a living, breathing tissue. And realizing this one single thing, well, it changed absolutely everything. So, if the sclera is alive and it's changing, what does that even mean? It means our eyes are active players in this whole game. They aren't just passive cameras recording the world. They're actually reshaping themselves.
Okay, and here's a super important distinction. You have scleral growth. That's when the eye adds more tissue to get bigger. That pretty much stops when you're a toddler. But then there's scleral remodeling. This is different. This is where the existing tissue just reorganizes itself. Think of it like rearranging the bricks in a wall without adding any new ones. And that process, that remodeling, it continues for your entire life. And that is the key to this whole myopia explosion.
It's a pretty wild idea, isn't it? The thought that your eyeball is just constantly tinkering with its own shape. So you have to wonder, how in the world did scientists figure this out? Well, the proof came from a series of absolutely brilliant and, I gotta admit, kind of weird experiments that involved some very, very tiny test subjects.
Yeah, meet our hero, a tree shrew, wearing glasses. I'm not kidding. Scientists actually fitted these little guys with custom-made lenses. By changing the glasses, they could make the shrew's world perfectly sharp or consistently blurry. And then they just watched to see what the eye would do. What they were testing is this incredible process called emmetroposition. You can basically think of it as the eye's built-in autofocus. It's this active, visually guided system that's always trying to adjust the eye's length to get the picture just right, perfectly focused on the retina. So here's how the experiment went down. Step 1, they pop a lens on the tree shrew's eye that makes everything blurry. Step 2, the retina sees all this blur and starts sending out these little biochemical go signals. Step 3, the sclera gets those signals and starts to remodel itself, to stretch. And then, step 4, and this is the amazing part, the eye physically gets longer, just enough to cancel out the blur from the lens and bring everything back into sharp focus. This was revolutionary. It proved the eye isn't some fixed piece of hardware. It is actively, physically changing its own shape based on what it sees. Blurry vision literally told the eyeball, hey, you need to get longer. Okay, so what in the world do tree shrews in tiny glasses have to do with you and me and this global myopia boom? The answer is everything. Let's put the pieces together. All right, let's connect the dots here. We know a myopic eye is too long.
We now know that getting longer is caused by the sclera remodeling itself, and we also know that remodeling is triggered by visual signals. So, here's the powerful, inescapable conclusion. Our modern environment, all the close-up work, the screens, the indoor living, it might be sending our eyes a constant, non-stop signal to grow.
And this completely reframes the whole problem, doesn't it? Maybe nearsightedness isn't a defect or a disease in the way we usually think about it. Maybe it's the perfectly logical, programmed response of our ancient biology doing exactly what it was designed to do, adapt to a brand new world it has never seen before.
Which, of course, leads to the most exciting question of all. If we can trigger this remodeling, if we know the mechanism that makes eyes grow, can we also control it? Could we use the same system to slow it down, or maybe even stop it? This is the absolute cutting edge of myopia research right now. So, the next time you look in the mirror, just remember this. The white of your eye isn't just a simple static shell. It's a living, dynamic tissue constantly remodeling itself to match the world it sees. And that is a pretty amazing thought.